Good afternoon, everybody. Yours truly here, Fusion Phil over at jitcadcam, and we are back to yet again another free support Friday, where we are here to help you guys with any questions or problems you had throughout the day or any issues you're having inside of the software. And we even open this up to interesting workflows and very, very curious types of things. Like I'm going to kick this week off, which is going to involve building out a self-centering vise, because everybody wants to know with the motion link how it works, how to set it up. We're also going to look at a little rotary toolpath this week, a little 4-axis live machining for a part that would be on a horizontal. But with that, there's no better time than to start everything off right, which is we're going to, of course, crack it open, another energy drink, and get this thing going. And as if you watch my videos all the time, or if you don't, feel free to subscribe. You'll notice that as this goes on and the energy drink hits, we pick up the pace quite a bit. So let's jump into this. So I'm going to go ahead and share my screen for you guys. As you guys can now see here, I've already imported my model. Now, very important couple of things right off the start for anybody and everybody is the ability to have your model structured with components. This is very, very important. As you guys can see with the component structure, it is not individual bodies. It is very easy to convert a list of bodies by right-clicking, create components. But this is going to be the big thing that changes how you do and how you work with joints later. Now, me personally, I'm an organization kind of guy. I like to make sure my stuff is pretty streamlined and easy to use. So I am going to separate this into basically 3 categories. I have the base, I have the back jaw, and the front jaw. You could also use L and R, all 100% up to you the way you label this out. But let's go ahead and start by creating a brand new component. And again, I like to start with base. So here is my base. And then from there, we can go ahead and reactivate the top level. But what we're really looking for is to go through and pull any items that work with the base and only the base. Now, a trick here to utilize is if we turn the base component off, anytime we drag and drop something in there, it's automatically going to disappear from our assembly. So as you guys can see, I now know this shaft here is going to be something that needs to also be moved. Now I can go up to the top. I can highlight again, click and drag. Another kind of trick out there for you guys, if you didn't know, if you highlight, and I just did a window drag highlight, it's showing me over here on the left with an underline of everything in blue, to which will be grabbed. So again, I'm going to hold control now, grab all those individual items. Again, we're throwing those all in the base at the end of the day. Looks like I missed them here. Let me go ahead and do that again. Control, click, drag, make sure we're on the right location, and release. So it looks like it's giving me a little bit of a trouble. Let's go ahead and see that one more time. Is it me or is it the software? I know I have a pretty good track record of doing things wrong. It looks like it's not liking that control. However, if I individually place these, you guys, again, you're seeing that in real time, that we can go through, highlight the items that we need, and move them down slowly. So again, grab that next grouping, bring them down, and just like that, basically my base is organized. So again, guys, I see a lot of you starting to get in here. We've kicked things off already. If you have any questions at any time, feel free to throw them in chat. You can also scrutinize if my audio sounds off or if I sound too loud, sound too light. But again, we're going to just continue on this process, right? So one thing that did happen is along the way, I did click and drag something, which means it moved. We could always revert that back, but I'm just going to rinse and repeat the process. Again, new component. Let's say this is our left jaw. And basically the same thing all over again. So we could take all of those components that we want, place them in the left jaw. Again, the tip here is to turn them off on the move so that we can make it very easy, knowing that they disappear. So again, it looks like we're still having that problem once again. Maybe somebody out there can tell me what I'm doing wrong. I think I'm just moving too fast. But one last time around, right? So again, we activate the top level to make our life easy. Again, we're going to go jaw right here. And then the last of everything can basically be placed inside there. So the idea is with the organization, we have made it very simple for us to go through and be able to turn on and turn off things as well. When we start to join these together, it will make much more sense. But if I go up here to the top, we're going to go ahead and show all components, and we're going to go ahead and do show all bodies as well. Now, I did notice I was having this kind of problem before. Oh, of course, I'm not in the active component. That would make sense. As you guys can see now, all of my components is shown back up. We have organized things. The next step is crucial because everything is still individualized, is we're going to start to group things together. And this was the importance of that organization, because I can go through and I can now rigid group, and I can basically rigid group the entire base, right click, go to my 12 o'clock position, left jaw. One more time, we're going to go ahead and do the right jaw. And now if I go through and click on any of these, notice how I've rigidly grouped everything. So all the screws that hold it down, dowel pins, bushings in this case, even the linear shaft that everything is going to move upon. So as you guys can see, it was very quick once I got my organization down that I can now go back and add my actual joints. Now, the cool thing about this is we do have the ability to use as-built joints because everything is in its place where I want it to be. So again, we're going to do an as-built joint. Now, it doesn't matter if I use the actual jaw. I personally would like to go with the base down here. And then what I'm going to do is I'm going to put it directly on the actual shaft. And then with that, we're going to go ahead and swap out to a slider. Now, the direction of the slider, again, very important, because as you're going to see is I'm holding control on this cylinder surface, and I'm just grabbing the node that is on center of rotation. And as you can see, it's now sliding. Don't worry, guys. If you mess this up, by all means, you can go back. You could actually use an edge on the base too. Again, getting my mouse on that surface, holding control. Let's say I want to go over to this edge. And notice how that's going up and down. Well, I can change now and tell it which direction do I want to go off of. So let me go ahead and swap mine back just for demonstration purposes. Again, we just want that in and out motion. Now, I'm going to do this one more time. Again, I'm going to use the actual base of that vice jaw, use the actual shaft. Again, we're going to go ahead and do a slider. So I need to snap, and I'm going to snap again to center. And just like that, we have our inside-outside motion. Now, if I was to try to move these jaws, notice how everything's moving around on me. So this is where I either need to, in some way, shape, or form, pin, ground. Again, there's multiple options here. Or what one of my favorites is I actually like to use a joint to place bottom center of my vise onto my origin. And now you guys can see it's flipped it over to the side. Keep in mind that red line, that is our x-axis based on the world coordinates. So again, this right now would be a left and right kind of configuration across x. If I wanted it to face towards me, again, making it easier to get the wrench on to change parts out, I would need to rotate it 90. But as you can see, it is now sitting on the origin. It is now in the correct world coordinates orientation. And if I go to move one of these jaws, I can move them independently. Man, every time we do this, I got a mustache hair tickling me here. So as you guys can see, again, we now have motion independently for each jaw. I can revert those back one more time, get my origin out of the way because I don't want to stare at it. Stuart, great to see you out there. Glad to see you made it again once this week. But now we need to link our two sliders together. So again, if I go up to assemble, we're going to go down to motion link, and I'm going to grab both of those guys. Now, as you can see, they are moving in and out. So they do asymmetrical motion. Now, if yours wasn't doing a symmetrical motion out the box, if I go ahead and click reverse, you notice how they're sliding along each other. Make sure that they are going in and out as required. So as you can see, upon adding that motion link, if I grab one side and pull it out or pull it in, I have very simply now created, in this case, that dovetail or self-centering vise that utilizes those joints to always make sure that it is center on my base. Now I can step this up one step further. As you guys will see here real quick, is we're going to do a brand new component. Now I do recommend for a lot of you out there is you can pin the new component to your toolbar like I have, and you can actually drag it around and reorder it. However, I saw a very interesting video where somebody pointed out it's actually a better workflow to pick where you want that component to go. So if I go up here to the top and say new component, by default, that is the parent component, or in this case, the entire assembly. But let's go ahead and throw a stock in there, right? So again, we're creating our stock. I'm going to need a box for my stock. And now I'm going to utilize any one of these planes. It doesn't matter, but I'm going to draw off to the side my stock. Now, the size of your stock, again, this is something we can control with parameters. And if you guys didn't catch my last Wednesday video, we did a really cool video utilizing components, or not components, but using configurations to make your workflows even better. But as you can see, I now have my stock, and I need to put my stock in my vise. Again, because we're using components, we're utilizing the tree the proper way. We can go through now and actually put our vise onto our fixture. Now, you guys are going to notice here, I do have my actual dovetail. I did not model my dovetail. You guys can model your dovetail if you'd like. If you guys want to see that, let me know in chat. But I am simply just going to cheat the system as much as I can. And we're going to just do a joint in this case from bottom center of one side of my stock. And if I come over here, I could either place it on the flat here. Now keep in mind, it's going to be joint to joint. So if you're going to use the flat here, we should make sure that we're actually using the bottom of that edge. Again, showing you guys here, we're going to get over here. I'm going to snap that up into place. And now just like that, our stock is sitting on center of that surface, which necessarily isn't compensated over far enough. And we could simply do that if you wanted to. We could say inspect. Again, we could inspect surface to surface. We need to shift it 52 thou. Again, down in my timeline over here to, I guess, my left, I could now do a little bit of a shift by that 52 thou. Not necessary, guys. In most cases for your machine sim, you're not too concerned. You do have a little bit of lenience and a little bit of variation on what you're doing. But just like that, it now looks like it's mated up against that surface nice and tight, right? So again, I can go ahead. In this case, I can't repeat joint because it wasn't the last tool used. But if I went ahead and hit S on my keyboard, I could do, again, a search. Pro tips here for you guys to make your workflows better. Again, we're going to go off bottom here. Oh, wrong side of bottom. That's on me. Go bottom here. Center of this surface. And then again, we're going to compensate this that 52 thou. So again, negative 0.52. And just like that, our stock sits on our dovetails or serrated teeth, and it is in between my jaws. Now, yes, we've over traveled this vise. Again, guys, I can't self-promote. The component video that I did with the vise, or not component, configuration would allow you to automatically switch your vise jaws around. But we could go through, again, setting up our parameters, as you guys may or may not know. Again, I could just favorite these, and now we could adjust our stock size. So let's say it's actually, 2 inch by 4 inch by 3 inch. And just like that, I've updated my stock, and my vise has automatically self-centered, opening and closing in that case. So again, guys, let me know. I see a lot of you coming and going in chat. I see you guys showing up. Get a 3D connection space mouse. I can't live without mine. So I would do, and I used to do a connection mouse, but because I travel so much and I'm moving my laptop around, I know you can get wireless ones, guys. It's just one more thing that I'm taking on the plane, that I'm flying with, that I'm dealing with. Now, me personally, I prefer a touch screen. So let me know, is that going to help you guys out? Does that look like something interesting, something cool? Again, the key element to being able to get that actual vise to open and close with symmetry or symmetrical vise movement is the ability to do a motion link between those two slider joints, right? So let's go ahead and pivot here. I don't see a lot of questions today. What are you guys up to that you're not asking questions? You guys busy running machines out there? I'm going to go ahead and shift gears over. We're going to look at a lovely 4th axis part. Now I say 4th axis because the request from my customer was to basically take this part and reduce the amount of setups and reduce the amount of headaches, because we have very small fillets on this part that are being required to be reached from a very long tool, which is going to make tons of chatter. So crazy snowboarder, that's exactly how you made your self-centering vise. Great to see it. Did it last Wednesday, though. I never thought about using a config for that. Yeah, the config is nice. I'm telling you guys got to go. You got to sign up for the notifications. Check out the latest stuff on my channel. So let's go ahead and start by jumping over to the manufacturer workspace. Now, in the case of a part like this, for you at home wondering, is this part diameter is a 9-inch roughly on this diameter. So I shouldn't say roughly, it is 9 inches per the model. But that being said, this is where it is a bigger part, right? You might be able to spin this in a lathe, but when it comes to machining and trying to get down here and machining these very, very small radiuses, again, that's a 1/4 inch or an 1/8 inch radius, which means I need a 1/4 inch tool to get in there. This is where we have the ability to move to maybe a 4th axis, whether it be a horizontal or a vertical. The whole concept is still going to be the same, and it is very easy to do inside of Fusion. Now, I want to show you guys an inspection tool here that is going to help you out if you're dealing with parts with small radiuses, as well as the accessibility. So one really neat thing, again, is we could say minimum radius analysis. And then with that, we could go ahead and adjust. So if I was to bump this up to 125, you're going to notice that I'm not going to get anything. But if I slide it up just a hair above, so again, as if I went 126 thou, anything in red is a radius smaller than 126. So again, that 1/4 inch radius, you're going to go, oh, wow, how are we ever going to reach that far down? That's pretty crazy at the end of the day, right? So let's go ahead and start our tool pathing. Again, this is a neat thing about this is if you turn on minimum radius analysis, it will stay on by default. So we can always go back to our design tree and delete this. So given that they are turning this part is coming out of a cylinder. So again, we have a not relative, never use relative size, please. Always use fixed size tube in this case. We now have our raw material for machining. And with that, we could go ahead and do either end of this part first. It really doesn't matter at the end of the day, but we do need to pay attention to creating the profile on the inside of it. So again, another pro tip here, guys, is we could do a section analysis. It's very important that you do section analysis after you do your setup, because all of your tools come in on X. So it would be wise to do your section analysis on the same plane, allowing you to see whatever is going to happen on the inside of your part. Now, again, based on the bore here, we may need to actually backbore this. There's a lot of different ways we could do this. I'm just going to get a couple of simpler tool paths on this part to make our life easier for when we flip it. So again, we could go ahead and do our profile roughing. For those of you that don't know me, we're going to go ahead and grab some simple tools out of the library. For example, here's a right-handed roughing tool. And just like that, we're running the full length of our part. So we do need to make some changes and some adjustments. Again, this is where we could say, you know what? Maybe we want to go Z the opposite direction. Now, again, this is very important because unless you want to see your tools coming down in X with your Z in the proper orientation, you may want to flip your X at the same time. Again, based on that information, when you set your tool paths up, you'll be able to see them now flipped back the other way, as if it's running the machine. Again, your actual tools coming in on the proper side. Now we're going to go down. We're going to turn off our stock visibility because I just want to see the lathe side of the stock, which is the spun profile of what we're doing. So again, there's our OD roughing. We could go ahead and swap that out for some finishing. And the idea is we're just working through this part as if we would any other time, or if you guys are running these are in your shop. Again, we're going to now go ahead and do our profile roughing. We're going to swap out to a boring bar. And what I'm really trying to do is just push my material through as if it was when we actually got to machining it, right? So the key element here is, as we would have, if I turn the old stock back on that I just turned off, is the stock model that I'm getting is going to help me a ton when we get into rest machining later. So again, we'll get that turned back off. You guys are seeing this. We're going inside again, derive, turning, profile, not roughing. That's on me. Turning, profile, finishing. And just like that, we have our finished toolpath inside of our part. So let's go ahead and start our next setup. So I'm going to go ahead and jump in, new setup. This time around, we're going to be on a mill, and we're going to want to go ahead and set our Z-axis. I'm going to set my Z-axis up. And the whole reason behind that is going to be we're going to now machine basically the flange on this part, allowing us to have something to hold on to and to indicate off of. So again, we can turn that section analysis off, and we could start all of our tool paths all over again. Now, there is a lot of arguing one way or another is, do you do stuff with 3D or do you do stuff with 2D? In my opinion, on a simpler part like this, it might be quicker just to hit the 2D adaptive clearing and go in and pick my tool and just pick a couple of edges that I need to machine. So again, flat end mill, good old 1/2 inch end mill. Geometry here is going to be that profile. Now, the reason why I'm picking the top profile is if I was to pick the bottom profile, I would have to make sure that I traced it all the way down and around. Again, the idea here is simple geometry to create these tool paths. And then I am manually overriding things like how deep do I want to go based on that tool and that type of information. Again, we're going to go 100 thou down past. And now you guys can see we're roughing that part out. Let's get our stock turned back on. Now, one thing I want you to look at here is if you notice, this is actually a good example here. Due to my flute length of my tool, we have this little overhang happening. Again, I see this brought up quite a bit. So either I need a longer flute length or I need to turn on multiple depths. So again, let's go ahead and throw on the old multiple depths. Now we should get a couple of passes. We no longer get that overhang. And just like that, we're now roughing out that flange. Now I could add in there another roughing strategy, which I think I'm going to. And we're just going to do the inside of this part. Now, something I want you guys to see here is when I went in and I added that inside chain profile, again, it's starting from my stock inside by default, but we've turned that inside diameter. So again, this is where 2D, I could do some manual things like, hey, override my stock, and my stock is actually from here to here. And then trim that tool path down so that we're only machining the shoulder. So again, we're going to go ahead and now hit this all with some finishing tool paths. Same exact thing. We could go ahead and define our geometry. Let's just do the inside one first. There's our inside profile. Again, getting to the outside. Same thing all over again. And you could have derived these on your guys' end. Any questions out there from anybody? As you guys can see, today seems to be a very lack of questions or curiosities kind of day. So I'm just going to keep ripping through this part. Now, this does remind me that as you guys can see here, is we do have these flanges. Now, I wouldn't want to machine these until we get on the 4th axis. So I'm actually going to change the actual contour that I'm using around my part. So again, by default, it was a closed chain. We could go to an open chain. And as you're seeing me do is I can bring that chain all the way around to a stopping point. And that stopping point, as you guys are seeing, is no matter how close I get, it was still looping. So I'm going to add a few more segments in there. And then we're going to add a second chain for just this little hump over here. So now, if I get this spun around, we're going to be machining and stopping before we get to those flat areas. Now, there's one more thing we're going to want to go ahead and do here. And that is let's go ahead and do a extension on these. So again, as I can align and extend with a highlighted left or right click, we're going to go 3/8. We're now seeing that little tail here, right? And just like that, we've now finished those outside profiles. We don't have to worry about touching these walls, to which we're going to machine later anyways. So as you guys can see, we're slowly narrowing this down. I'm going to skip over the chamfers unless you guys want to see it. I don't know what you guys are doing out there in chat. I see all you guys out there, but nobody's talking in chat, which is strange for this show. But let's get to what some of you are probably waiting to see. Is we're now going to move on to our next setup. Like I said, I'm going to go ahead and program this as if it's actually going on a horizontal machine. So this is where I'm going to choose. In my case, I like Z and Y for my horizontals. And I can square up to this flange. My Y-axis is going to be based on the inside cylinder. We need to flip Y. And then I'm going to utilize a selected point. So given the fact that we have some nice machined edges to go off of, we're going to go ahead and define that up at the top. Tim out there and Emil, awesome. Great to see you guys. What's going on, Tim? It's Bill. Yep, his evil twin. Wait until next week if I cut the mustache off, and then I'm Will, the other triplet. So we got our XYZ set. Again, stock from preceding, guys. Pro tip here, don't mind. Go ahead and click that box and then go over to these three little dots and save it as a user default, because I promise you, you will almost never need continuous rest machining turned off. You missed the opening? Tim, you did miss the opening, but actually Wednesday's video is the one where Phil's evil twin was taken over. But now we can get into our fourth axis machining, right? Again, I'm going to leave this up to you guys. I'm going to make this as dry and bland as possible. Do you guys want to see me put this on a horizontal machine? I don't know. Let me know in chat. So let's get to our roughing. So what I'm going to do is I'm going to go to multi-axis, and we're going to go down to our rotary pocket. And with rotary pocket, you may want to go to a larger tool in this case, but by default, we need to define a rotary axis. Again, we're going to go around our setup Y because we are on a horizontal. Now I'm going to go ahead and shift over here a little bit. We do have our stock front, our stock back. We also have the ability to utilize rest machining. And as you're going to see, we're going to go ahead and hit OK and let this go. Now, Tim wants to see this on a B-axis lathe. And the great thing with Fusion is we'll be able to move that over here shortly. So let me go ahead and get just a tool path to start. And as you guys are seeing, we are getting quite the tool path. So we are now roughing out everything around this part. Again, this is all going to be based off utilizing a rotary roughing tool path. And we can machine this. So as you're seeing, again, just a very quick way to go through machining out all that material. Now, this is where things like hotkeys become your best friends, because you're starting to see one, for example, that tool doesn't stick out far enough. So I may need to update my tool. And the reason why I say that is if you guys look, let me know if you guys can see this. I can also change the settings, but I'm getting what's called pull away. I'm staying away from that actual wall because my tool holder is getting too close. So again, we go back in, and because the shaft and clearance or shaft and holder clearance settings down here, that is what's causing that effect to stay away. So again, we're going to edit that tool. Let's stick it out just a little bit further. Very easy win. So again, we're going to go into cutting data. Actually, we're going to go back to cutter, and then we're going to go ahead and stick that length out to maybe 1.5. And just like that, we should have better clearance, allowing that tool path to get more room. So I am going to have to regenerate everything here, but it will go relatively quick. Now, I will say for a lot of you guys out there, I do a lot of screen sharing and helping people out, but I do have to say that given you've gotten a newer computer in the last 24 months, the performance is night and day difference. I hate to say it. I hate to be the one to tell you guys to buy new computers, but I have seen some 9th gen Intel computers really start to struggle and not do an instantaneous update, as you guys are kind of seeing here. So as you're seeing now, we went ahead, we've gone in, we've implemented our toolpath, we've now roughed that out. Now in Tim's case, Tim wanted to see something like this happen on a lathe, right? Well, if I wanted to move this toolpath at any time, I can take this toolpath and I can actually drag it all the way back up to the top. Now, this is where we are doing our turning toolpaths, and I can regenerate that toolpath. Now, what is going to happen? Again, it's got to recalculate because of the rest machining, and we'll give it a second here. But we're going to see a lot more action when it comes to machining basically all these little cogs around the outside. Again, that's why this toolpath is now starting to take more time to calculate. But you're going to see it here. Let's go ahead and hit F7 so you can see the toolpath. It looks absolutely terrible. And the reason for that is, can anybody guess? I'll give you guys a second to guess. Oh, Going once, going twice. Tool angle, it is partially the tool angle. Yes, Tim. So if I go back into that toolpath, initially we were basing everything on setup Y, right? Well, in the world of a B-axis machine, we would actually be utilizing that with the setup X or the setup Z, right? So again, as if I switch my rotary axis out, as you can see, yes, somebody crashed the machine. Actually, I think this will error out before we get there unless you're on a Doosan. And we could try that. You guys want to see this? Hold on here. Let's say, for example, you're living frisky, right? And you're like, you know what? I want to machine this toolpath. Well, if we were to post this out right now, and the reason why I say this is if we were to go into our library, and if you are somebody with a DN Solutions, or you're utilizing their post processor for the mill turn, is we're going to go ahead and copy this over. As you guys know, we're going to put this in a folder that I can throw away later. You guys notice I cleaned my folder out too. So let's go ahead and edit this. And the reason for this is because this this post actually has the ability, B-axis is manual. So if you have a manual B-axis on your machine, just like that, you can actually get set up to utilize it. So again, something really neat at the end of the day is based on that information. By default, it is currently on for the Puma as well as some of the others. But with a manual B-axis, when you post-process, is I believe it's going to tell us what angle that tool should be at, or it's going to fail because in this case, direction is not supported for machine configuration and a lot of other things that we would have to walk through. So again, this is where I might actually have to go through, set up a machine. Maybe, give it a sec. I think it paused. She's thinking. There she is. First and foremost, it looks like we lost our Z-axis. Let's hit cancel here real quick. I think I freaked it out. It did not like that one bit. There we go. Select our machine. Again, I've seen this quite a bit as well. Let's see, where can I stick this one? We'll put this one in my local. So I saw a post about this on Facebook. Is somebody had some problems with the kinematics when they were trying to post. That was just a simple TL Haas lathe. But as you guys are going to see, is we're going to go ahead and do a generic dual spindle lathe with live tooling. Now, I can't stress out how important the kinematics tree is, but this stacks up the same as it does in the machine. Now, what does that mean? Well, your x-axis sits on the z-axis, right? And if you were to add in a y-axis, the y sits on the x. Again, this is very important to understand when it comes to stacking this thing out. Now, again, we could add in a rotary, and that is going to be a B-axis, and we're going to call it a B-axis. And as you guys will see, is you have a lot of control here. And as you're going to see down below, this is a prompt for manual positioning. And as you're noticing, is I'm now adding in the exact features of my machine. We're, of course, going to give it a post-processor at this point. Why not? And then from there, if everything is working correctly, let's go ahead and here. Perform select operation on an invalid machine assets. Woo! We're getting good. Let's go ahead and see if we can back this up and fix this here. Let's see what is going on. I'm going to go ahead and move this toolpath out of the way. Again, this is why you guys, I think, show up mostly, is you guys want to see me screwing this up, right? People like fails more than they like success. Again, let's go ahead and cancel that out. Did not perform operation invalid. All right, let's go ahead and edit our machine real quick. I have a feeling it's something to do with the B-axis. So again, we're going to go into that B-axis and let's just say, oh, you know what? Our range is probably off. So you really actually have probably negative 180 to 180. And we're going to go ahead and just do machining. And it looks like we still have the same problem. So again, this might be on me, guys. Give me a second here. Capabilities, milling, turning. You'd like to see my computer freeze as much as yours has. So again, I would say that if I moved a little bit slower, I wouldn't get it as bad, but I am pretty crazy in the world of pushing this thing quite hard. Let's go ahead and take a look here. Z-axis C, let's see. Let's go ahead and pull this B-axis off real quick and see if it's still happy. Nope, it looks like yours truly has broken something here. So we're going to do what I always tell people is sometimes it's easier to go back, start fresh. Let's not change anything and see if we still get the same error at the end of the day. I don't know, guys. Is this me? Are you guys having this problem out there? It looks like we're having a good one. This might be a bug. I don't know why it would be a bug, but I'm speechless on this one. Let's go ahead and go back. Post, multi-axis, yes. Kinematics tree looks all right. I wonder if it's actually, it shouldn't have Z2. No, I'm speechless on this one, guys. Let's see here. Let's go in and do, where is it here? Machine simulation. There is a Autodesk machine simulation only post. And see if that fixes our problem. It does not. Cannot perform select operation. Huh. I'm waiting for you guys to tell me in chat if you guys have the same problem. Again, we might just have to start. Let's start with a brand new setup. Can we pull it in now? We cannot. Invalid machine asset. What do you guys think? Is this me? You guys having this problem? There is no machine. There is no machine builder. Man, I assume there's not actually any. There's those. Yep. Just double check everything over here real quick. Turning. Let's see here. I wonder if any of my old ones still work. Huh. It looks like all of mine are junk. Who would have guessed? Again, I'm going to let you guys tell me, can you select a machine on the lathe? Because apparently I can build a machine. I can't select a machine all of a sudden, which leads me back to the whole thing of let's go ahead and redo these toolpaths back the way they were. And I think I'm missing something here real quick when we post process. I'm going to let that tool calculate real quick. Multi-axis, TCP. If not, I got ways around this. We could cheat the system. E-codes for spindles. I'm not seeing. Got multiple turrets. Puma, AC. Okay. Give it one more go. I've really angered it now. There we go. We're still going to get the fail, I have a feeling, but we're going to take a look at something. Again, guys, any of you out there that are new joining, feel free at any time to throw some messages in chat. We've now got code. Direction is not supported. For machine configuration, yep, we're going to go ahead and make a couple of changes. Pro tip again for you guys. This is why we do this. In the Fusion library, there is a, not to say secret post, called the export CNC file to VS Code. I think I show this every week on this channel. That is going to spit out basically all the toolpaths that I select and prep them so that I can run them through the post menu and see what's wrong with them. Yeah, I probably broke something. We might have to restart Fusion. Who knows? Pro tip on that stash. Yeah, I got good genetics, I guess. There we go. We've got our NC file output. And what we're going to do is we're going to do post one more time. And the idea here is we're just going to grab that other post and hit edit. Again, we can now go into our CNC selector here. You'll have what's called a custom, and then based on the file, 1001 in this case, as you're seeing, direction is not supported for machine configuration, 1099. Over here on the left, we could scroll down. And we're looking for line 1099. As you're going to see here, 1099, down a little further, is, am I crazy? 1099, 1099. Optimize accesses, which again, I think this is actually going to come back to the fact that we search Puma. I feel like I've had this problem before. Actually, it's, where was it? Also, another pro tip, guys. If you're somebody that has now gone to Windows 11, you can enable the ability to push Window V, and you could pull up everything that you have done and recopy and paste. It's probably one of the nicest features in there. So again, the competitor. Oh, you work for KUKA? Nice. So again, we're going to go back up here. Let's just go ahead and double check everything over. Version Puma, true. There's probably a B-axis limit area. Where is it here? Y-axis limits. Yep. Let's go ahead and look at B-axis now. Got B-axis, yes, but we need the machine configuration. As you guys are seeing here, we now have -90 to 45. So it does look like we should have the machine travel range. On this one, I might just chalk it up to a loss. We're just going to go back to the original intended area. I should check one other area. What machine do we have? We are on the Puma machine. Okay. I'm going to double check a few more things. Because we do have the B-axis enabled, but it might not be liking the simultaneous machining. Try this one other way here real quick if you guys are super heart set on this. Let's just say, well, obviously that's not going to work. We're machining the wrong direction. Right, guys? This one's on yours truly. All right. So technically, let's do this. We're going to go ahead and swap this out to our other setup real quick. Let it calculate and see what we can come up with. But trying to see, we do have a feature here. If we were doing milling, just say we're going to do a 2D contour right here. I'm going to tool orientate to that surface. Now that surface is at 45 degrees. I already know that for the record. So again, we're squared up 45 degrees to that surface. Again, I could adjust my x-axis if I wanted to run across X or Y. And then we're going to go ahead and give that a tool, of course. But what I'm looking for is a simple 45-degree angle toolpath. I'm going to post this out. We should get a successful toolpath, but we did not. Direction is not supported. So again, we're back to that direction is not supported. I'm going to have to possibly restart my Fusion here, guys. So again, we should be getting a B-axis tilt for cutting that bevel, but we're not. So again, let's just go ahead and get back to where we were talking about doing this on a 4th axis rotary. We'll come back to this problem when you guys chill out and chat again. So again, we're doing our rotary toolpath around our part. We could actually remove that. Our stock is going to come through automatically, which is nice. And we're going to have to just recalculate this one more time because again, rest machining. It's good, but also bad. Hey, George Roberts in the chat. I do have the Puma pulled up, George, and I don't know how long you've been here, but I'm having machine definition problems. However, I'm going to restart my Fusion here in a minute. Yeah. I mean, obviously it's Evil Bill. Evil Bill installed hacks, and he has ruined my system at this point. But as you guys are seeing, we are back to the rotary toolpath working around this part. Again, the whole idea is let's go ahead and simulate this. Now, for you guys that don't know, George Robert in chat, he is, if I remember, George, you're on the simulation side of things now, right? But he's a big part of the fact that we now have the fastest GPU simulation, which is probably the best thing I've ever seen. So when I go ahead and hit play here, notice how fast we can actually simulate out and run everything on this part. Again, This is probably one of the best things about the update lately, is just going in and being able to quickly simulate and get those results. But for you guys wondering, we're going to go ahead and slow that back down. Let's go ahead and restart this. But what we're looking at is basically this part. Again, we're going to go ahead and swap out from model and just go to tool so that we can see where it's working each and every time. Getting a little hectic here, but as you're seeing, we're now working in a couple of little blemished areas as we're moving. So we're going to have to go ahead and adjust because, again, we have those chamfers on the backside that it's trying to do the actual chamfer on the backside. He is the product manager. So guys, now's your chance. See, this is why I love doing this, is because he's going to come in here. George, you're going to have to tell me, can I show something else off that would work for this or not? I'll let you answer in chat. But again, guys, what you're seeing now is that rotary toolpath roughing back and forth across our part, roughing everything out, opening up all those areas. And again, great toolpath overall. I like every bit of this, as you guys are seeing. Now, a few things I would change on this right off the start is I would actually, instead of doing my rotary first, I think me personally, I like the idea of using something like 2D adaptive clearing. And the reason for this is I can go in and I could rough out very specific areas. So again, let's say I want to take these flats down to work with. As you're seeing me do here, I'm going to go ahead and do my open chain. We're going to go ahead and reverse that. And then from that, I'm going to go ahead and give that a stock boundary again, so that we may only rough in that area. Again, the idea is to knock down those humps and the flat areas. I need to go ahead and order this the right way. Let's get back down to my other toolpath. And again, we just want to rough that out so that we're not wasting our time with the actual rotary toolpath. Now, again, pro tips. We have tons of pro tips over here, tons of ways to make your life better. As you guys saw, we were trying to actually machine the chamfer on the backside of the part that we've yet to machine. So as you guys are seeing, if I was to add back up when we actually do that flange, right? I need to go in and I need to add a 2D contour for that chamfer. And in this case, I'm going to utilize a spot drill for this. So again, we go back to our Fusion default library, tried, true, and true tested tools. Another pro tip, when you guys are having toolpath problems, try going and getting one of the default tools, as it may help you. So again, we're going to give this a little offset. Now we're putting that chamfer on our part. Again, we go ahead and move down to our continuous rest machining for our rotary toolpath, and we'll let that calculate again. So go over how to prevent Cherokee repositioning moves on an older control with simultaneous 5. So if you can send me an example or give me a couple of examples, I'd be happy to look at them. So again, as you guys are seeing, simple enough. I added a toolpath higher up. Continuous rest machining has now picked up on the fact that we're not touching the backside chamfer anymore. We are still getting a couple of toolpaths up top here. Again, this is the fun of being able to manipulate your model on the fly and change things out. So this is the pro tip I was leaning towards, guys, is if you guys didn't, I have a video on this. It's called Simplify. But if I go back to my original model, what I always tell people is you never want to modify the original customer part. So we're going to copy and paste this guy. And then, of course, we're going to call this the original gangster, OG, or in this case, let's call it the original OFF, right? The original Fusion fill. And then we have our Bill version. Again, evil Bill, right? So as you're going to see me do is I can now go under modify and I can go to simplify. Now, if you're not seeing simplify here, guys, is down on your timeline. You want to make sure your timeline is turned on. And if your timeline is not turned on, that's probably where you should have started. So again, you want to make sure that you're activating your timeline by clicking that top component and turning it on. But now you're going to see me do is we're going to go simplify and I want to remove features. Now, the cool thing about this is as soon as I pick my part, you can notice it basically highlighted everything for removal. Now, in this case, I only want to remove things like maybe holes or chamfers. So again, as I can go through here and I can say, take all the holes out of my part, I could also remove the chamfers as well on the fly. Again, the real power and the real beauty here is that I can reverse engineer my part. Now, for you guys out there that are like me, that are used to the old hold, control, and delete, this also has the power at the end of the day that, let me go ahead and close this out real quick. We're going to undo that. And let's go ahead and repeat that. But if I pick my body, I can also do manual feature selection, right? So if you remember, or if you've ever done it, you've gone through and picked certain things. This is going to auto chain and try to grab all of that feature in one shot versus you holding control, misclicking, and having to start over. So again, let's go ahead and grab all of our holes, all of our chamfers. We're going to delete those, hit close, and then we're going to jump right back over to the manufacturer side of things. So again, depending on your toolpaths and what you're doing, we could very easily, instead of relying on that rest machining, I'm going to go ahead and remove that chamfer here real quick. But for this rotary toolpath right now, I may actually want to add in an additional model for machining. So again, as I could go down to model, I can now go out to where that model resides. Again, components here, guys, are going to be very, very handy. But now the model is going to be added in, and now without a chamfer on the model, it's automatically, again, avoiding those areas and skipping over what it can and cannot do. Now, I do need to go back to design because when we removed our features, again, you guys can see that we pulled all the holes. We didn't grab every hole, and that's because I didn't turn my feature sizing up. If I go too far, I'm going to remove my bore. So again, we're going to go ahead and scale that back a little bit, just enough. We're getting both of those holes. Again, we hit OK. I jump back to manufacture. Once again, we're going to go ahead and hit this guy with that continuous rest machining. And we're going to see that rotary toolpath no longer bore in those areas. So I did see some questions come up. Do I have a super powerful computer? So technically, by the standards of computers, I am on a newer computer. I will pull it up here in a minute. So I get this question. I don't know why I feel like every week it's the same question. Now, I tell you guys, I always send people to Dell at the end of the day. It's just, in my opinion, Dell's support is top tier, plain and simple. But if I went ahead and I go and look at computers, now I always tell people go for gaming computers. Now I'm on a laptop. So again, I went with an Alienware laptop. So let me go ahead and pull this up. You don't need to spend what I spent on a computer. I just want you guys to be aware of that. I am using this thing day in and day out. I'm streaming videos. I'm doing a lot of things out there. But if it was me, if I had a desktop, now I would go ahead and probably buy a desktop machine. Now on the laptop side of things, again, you guys don't need something as powerful as this. This is state-of-the-art, top-of-the-line type of setup. Again, not necessarily needed, and it's a hefty price tag. There's other options out there if you guys were to shop around. Again, if we went into, gaming laptops as a whole, there's some older machines that you could start picking up at a lower price tag. I even refer a lot of people over to Walmart as well. I would just tell you guys, make sure you're getting 32 gigs of RAM, right? Again, same ruling on the desktop side of stuff. If I went over to a desktop, again, gaming desktop computers, you don't need to be spending this amount of money. I actually think I just referred somebody to something like this. $1,500. You're still getting one of the top of the line processors out from Intel. You're getting a very good graphics card, and you're even wrapping that all up with the fact that you're getting 32 gigs of RAM out of the box, right? So again, let's jump back over. As you're seeing, we did that rotary roughing. I want to get pivoted here real quick. Again, guys, the whole concept here is we're trying to rough out this part. Again, we can clean this toolpath up a lot more from here. And as you guys are seeing, we're still roughing in where those little chamfers are. So let's go ahead and double check something here real quick. So when I added my model in, let's go ahead and turn off the setup model and see if it still tries to do it. Now, I think I could be a little also shaken here because we never actually faced off our part. So maybe we should try that real quick. Let's get back to our other setups, throw in a couple of facing cycles here, and see what we get. So again, we're going to go down here, throw in another facing cycle. Actually, we won't be able to throw in facing here. It'll have to be a mill facing toolpath. And let's see what we get now at the bottom. Yeah, I mean, George, you're 100% correct. Screen resolution does play a big factor. Now, I will say Fusion looks amazing at 1440 and what is it? What is that? Is that 2K and 4K resolution technically? But I'm still using a 1080p monitor. I like it. I stream with the 1080p. It works quite well for me. So as you guys are seeing, we're still getting some issues on the backside of our part where it's trying to machine somewhere where it shouldn't. Now, George, now that I got you here, we can hold you down. It would be nice to really see a uniform rest machining situation, right? So again, the older rest machining from previous versus some of the other things when we get into like adaptive clearing, we get this nice fancy stock defined rest machining, right? So again, this is something that I would really love to see come into Fusion is the stock define as it carries over to all and any toolpaths. But let's go ahead. We're going to change things up, guys. We're going to go ahead and shift over because another big complaint on this part that I got from my customer was the fact that when we get into trying to swerve some of these areas out. So again, we're going to go multi-axis and we're going to go advanced swerve here. And again, this is where we should probably be in the right setup. That's going to fix a lot of our problems. Give me a sec here. We're now back into the right setup. But let's go in, we're going to do 3D, and we're going to go multi-axis advanced swerve. And then we're going to swap out our tool again because we're going to need a small ball end mill tool to do this. And let's go ahead and grab our ball end mill. And from here, small little 1/4 inch ball end mill. Now, again, it's very wise. At the end of the day, we are going to run into shaft and holder type problems. So something I would recommend when you're starting to get into 5-axis and multi-axis kind of tool paths is being able to actually crank the tool up or stick the tool out a ways. So for example, I'm going to just go 5 inches out of my tool holder so that I don't have to worry about the holder necessarily being the issue. We could always come back and adjust this, right? And again, on a part like this, unless you have a tool specifically in your machine already, we're going to be more than safe here. So again, we're going to go ahead and do our geometry. Now, what I would like to swerve is this wall, but I do want to follow a floor surface, right? So as you're going to see here is I am going to give it a floor and we're going to see what we get for this tool path. Now it is going to fail. And again, it's very frustrating when a tool path starts to fail and you don't know why. Now, what I usually recommend is starting somewhere easier at the end of the day. So again, instead of trying to get down in this tight little area, as you guys are seeing, is if I was to actually move up to maybe this surface here, we're going to see a change in the system as we're going. So again, we still didn't get a tool path, and that would lead me down the path of maybe the problem is that I need guide curves based on what I'm doing. So again, we're going to go ahead and give this a set of guide curves. We need an upper. Now we're going to give it a lower. And then we're going to hit OK again and see what we get. So as you're going to see here, maybe we are getting a toolpath and I have my stuff turned off. That is not the case. Again, our multi-axis side of things, we do have multi-axis all set up. We're actually supposed to be 4th axis here. Let's go ahead and swap this out. Funny, because this worked on their part quite well. So I might have to do a few more things here. Again, you can't always trust surfaces working. We're going to go ahead and switch out to guide curves, of course. Let's give this a guide curve once again. I always like taking it back to the basics. It works pretty good usually when I go back to the basics. So again, let's see, where's my tool path? Do I even have a tool path? It's always the good thing. We didn't get a tool path, and I'm going to just double verify we have our tool path turned on. And let's go back in here. We got our 2 guide curves. We have our floor surface. Maybe we turn off our floor surface just to start. Because really, we just need to get a tool path. So as you guys are seeing, is the floor was the problem here. As you're seeing, is I'm now swerving based on 4th axis on that surface. So again, the real element here is no matter how great you think you are at Fusion, getting a toolpath on your part can make all of the difference, right? So again, as if I wanted to now move this somewhere else, in this case, we're going to go ahead and grab our upper chain and lower chain and reselect those two. As now I would like to go down through here. Make sure I'm doing the lower chain first. We are. And then I need an upper chain, which is going to be this guy here. Again, what we're looking for is to just get a toolpath on the part. Now, as you guys are seeing, is I did get some errors here. And I didn't get a toolpath. And the reason for that is because we're trying to put the toolpath between the two rails, right? We have our lower rail and our upper rail. And that toolpath wants to take the shortest distance between those two. This is where I found adding in a floor surface can make all the difference. So again, we're going to go ahead and select our floor surface around. And again, we're still getting those dilemmas as you guys are seeing. So we may have to go back and reduce that even more. It's funny because it was so easy on their part. But when you try to regenerate a part so that you don't give away secrets, it becomes nothing more than the funnest of fun, right? So again, let's go ahead and see if we can't switch back to surfaces. We're going to try this one more time. It's one of those days, guys. It's just one of those days. Oh, let's go ahead and kick off guide curves. See what we get. And of course, now we're starting to get a toolpath all over again. So I'm starting to think that our problem is becoming more of our tool than it is anything else. So again, let's go ahead and edit our tool. Now that we have a toolpath, let's give it a little bit more flute length too. And let's see what we get. Do we get more of a toolpath or do we get the same toolpath? That's always the question. So we still got the same distance of toolpath. So again, let's go in there one more time. In my case, I'm going to go back to the old guide curve system. We have our upper, and then we do have our lower. And let's start with a smaller chain. Must be something on my end. George, you tell me. Am I screwing this up? It worked so good. It worked so good when I was in my support ticket. Let's go ahead and throw everything away and start fresh. Let's go for generic swerf. You guys remember the original swerf? It's quite a good time if you can't tell. Again, let's go ahead and give it our lower area. There's our upper and see what we get. And of just like that, the original swerf toolpath seems to be wanting to do it. However, advanced swerf does not. So again, this is one of those things. The problem is this is not a 4th axis toolpath. So that could be one of our problems that we are going to have if we try to run this. Also got the wrong tool in there. So let's go ahead and swap our tool out. But I did achieve getting a toolpath, which is always fun. Like so. It's too advanced. Yeah. How dare Autodesk be making advanced toolpaths, right? Let's go back for it one more time. We're going to go ahead and go advanced swerf based on 4th axis around Y. And let's see if we can't do the other one around the outside of the part. How about that? We're going to go ahead and do a guide curve. That is our upper. Maybe we'll cut it a little bit shorter around the outside here and see if that helps. It might be that I'm trying to get it to go too far and it doesn't like it. The fun of doing this. I challenge you guys, if you guys ever want a good time, just feel free to try to do toolpaths live for an audience. It's nothing but the best of times, I promise you. Go ahead and see what we got. I think we're still going to fail here. And if I have to, I'm just going to stick that tool out even further because I think it is coming down to the fact that either tracking the floor or the tool is getting too close to the actual part. So let's do that. Let's rip the tool holder off the tool altogether. In the meantime, anybody else, anybody have any questions whatsoever, feel free to throw them in chat. love to hear from you guys, what it is that you guys are doing, questions that you guys may have. I do have something else that we could work on here too that I think might help as well. Go ahead and grab this side. Give this one more go. Actually, right now, let's do this. Floor. And then we're going to add swerf surfaces in just to really anger everything. Give her a few seconds here. Man, we've already been going for an hour. Seems like 15 minutes on my end. Hey, we're getting more and more of a toolpath, which leads me to believe it's on yours truly. It's not on the software. So what I'm seeing right now is it's skipping over my holes as it goes around this part. So that might lead me more down that area of from bottom or from top. We should be able to get a toolpath, hopefully, knock on wood, which would lead me down to being able to duplicate this and do this somewhere else. Now, as you guys are seeing, the calculation time is really slowed down on my end. And with that is if you turn up your tolerance, another pro tip here for you guys, it actually equates to a much faster calculation at the end of the day. Oh yeah, the wire EDM video that's coming. It is coming at some point. So let's do this. You know what? We're going to go ahead and swap things out here because it does look like with the surface selected, it's thinking that it's skipping over those holes for some reason. So we're going to go ahead and remove that. We're still jumping around quite a bit. Make sure my chains look all right. Chains look all right. Again, let's get a little further in here. Tool extensions. No, that's not it. We could blend from top to bottom. It's not a big deal. Click on some multi-depths. And let's see what happens. Now we're getting a lot of passes. And we're avoiding some stuff, which leads me in here. It definitely seems like we are trimming our toolpath due to the tool hitting, possibly. Let's see. Let's give it some more flute length, right? All about getting that toolpath in the right spot. That's it. Once we get it in the right spot, it's much easier to deal with. Hey, look at that. This whole time, I have been fighting flute length more than anything. Who would have guessed? This is why this is so much fun to do, right? So now that we know that, let's go ahead and go back. Let's go from bottom. We actually don't need multiple depths. Go ahead and get that guy turned off. I have yet to turn that off. Ah, now it's off. But, hey, there we go. It only took 47 tries and half of the time that you guys have been sitting here probably laughing at me. But we have finally gotten a toolpath on the part, which makes life a dream. Now, again, this is where we may want to keep the original contour pairs, or we could add in additional ones. Now, this is where it always seems to get me, is if I wanted to add another set of uppers, because we would like to do this area, and another set of lowers. As you guys can see, we now have another area to work in. Same floor still getting tracked. We don't have any surfaces selected. However, I will need to add in these couple extra segments. Again, we want the tool tip to track those walls and to go down and around. Oh, and we failed. So again, like I was thinking, the problem is definitely going to be is that we can't do two separate areas at the same time. So again, we could duplicate that tool path. We're going to go in and then we'll just unselect our guide curves. Again, upper, lower, and just like that, we got our floor surfaces, and let's see if we get a toolpath. Ken, great to see you out there. Do I have any tips on achieving mirror finishes on a bore? 1-inch bore, 7 inches deep, currently using drill and a reamer. So presumably if you're really looking for a very clean finish, especially when it comes down to bores like that, you need to use a boring tool and an adjustable boring head, I should say. And you should be boring that. You shouldn't be reaming it. A reamer is going to scrape as it goes down, and you're definitely always going to have kind of a bad. Now, you could hone it as well. Something we do in the world of like the engine type stuff. If you guys haven't seen my engine content, is we actually bore it with a boring head, an adjustable boring head, and then you go in and then you hone it. And when you hone it, you can actually polish it and get a better and better finish. So that would be my recommendations, Ken. Now, we're going to go ahead and we're going to pivot here a little bit more. Guys, if any of you have been sending in support tickets, I've totally forgot about you. Let me get back over to my support system real quick and make sure we don't have any support questions. Give me one sec here. I don't see anything. Beautiful. Let me check one more place. Y'all are just having fun watching me struggle with programming today, huh? This is why. You guys just show this video to your boss. Your boss is all up in your stuff, and he's like, why does it take you so long? Be like, well, I just watched Fusion Phil waste 25 minutes trying to get a swerf toolpath to work. No problem, Ken. Glad to help. So let's go ahead and we're going to pivot one more time here because I wanted to show off the fact that when we start to talk about having to do a floor surface, in this case, this is where the Geodesic toolpath becomes very, very handy. So again, is if I had to go in and I needed to actually now machine the floors of this part, I can use Geodesic because it is a surface-driven toolpath. But of course, we got to set it up for 4 again. And with that, we're going to go ahead and do our surface. And we're going to do a scallop strategy to start. Now, we could change this up, swap things out as we go. And as you're going to see, we're going to get our live 4th axis motion around our part. It's going to take a second here. Because again, for your guys' sake, let's go ahead and get the tolerance turned up a little bit. Let's see what our cusp height. 125 step overs are pretty crazy, but we're going to see the geometric pattern that it creates, right? So again, now actually machining the floors of our part to create that 360 degrees, blend things in and out and around. Again, that geodesic toolpath works great for the floor of that cylinder, where our swerf toolpaths are basically machining out those fillets in the walls. Again, making our life a dream. And lastly, we would just have to come back and finish up these couple of extra features. That would be something where maybe you attack that with a 3D contour. Again, just like everything, we could always do a selected boundary. Now we can use face contours here if you wanted. Face contours is nice. I love face contours. It makes chain selection a dream. Tool center, contact point boundary, and let's see what we get. So again, as you guys are seeing by default, contact point boundary is limiting us. We may actually want to turn contact point boundary off. And then you'll see is we should get more of a wall down type of finish. Again, making that much easier to work with and much easier to do. So guys, let me know. How's this looking for you guys out there? Is this working? Is this not working? If George is still out there, not to put him on the spotlight, but again, some good old rest machining for Geodesic would always be great. We guess we could do a selected boundary, possibly. I don't know if it's going to work the best. Milan's here. Hello, Milan. How's it going? You guys, again, guys, do you have any questions at any time? Anything you want to see? We are starting to close in on the record here of views in this channel. I guess we could always trim this toolpath, right? We could say only do everything inside of here. And then we've limited it down even further, making for a good time. You guys really got me curious. You know what I'm going to do? I'm going to do this is one, we've upped our ante around here for ways to support this channel. We have now added lobsters to the menu. If you guys are enjoying this type of stuff, if you guys want to see more content like this or something in particular that you haven't seen or had curiosities about, feel free to obviously like, comment, subscribe. I'm not ending the stream yet, guys. Don't be disappearing on me. I'm just restarting my Fusion in the background so you guys don't have to just sit here and watch my computer. But you can make jitcadcam over here. You can easily move your software over to us, which is great. We would love to have you guys as our customers. We sell support, training, custom post-processor work. Again, anything and everything when it comes to the Autodesk product line. We also support products outside of Fusion. You guys may have seen our feature cam content as well as our part maker type stuff. But again, the likes, the subscribes, the notifications are all great. The sharing of our content, I can't tell you. I think I've seen myself, the old jitcadcam Facebook page, tagged in so many posts this week on the Facebook groups. But we appreciate it. We love it, guys. It definitely makes life easy for us. Let's go ahead and I'm going to get back into those part files now that I fired my computer back up. And we're going to see if we can't get back to what Tim was requesting, which is let's see this on a B-axis lathe, right? So let me go ahead and swap screens over. Also, by the way, guys, we appreciate the beers, the steaks, and soon to be lobsters, hopefully. So again, what am I doing with my life? It's not just me. We got to go to screen share. There we go. So let's get back into this. Let's see if we could select a machine on this. All right. Last question got auto-corrected. Old controller with inverse time has issues with jerky positioning moves. Any solutions? We'll go ahead and take a look at that here in a moment. We're going to see if I fixed my machine issue that I was having. I did not. Huh. That's a good one. I wonder if something else is on. Give me 1 sec here, guys. I got to go ahead and check my preferences. I would also assume that George might be messaging me in the background right now, emailing me directly to be like, yeah, got this problem. Kind of funny. I wonder, you know what? I checked what I needed to check. Can I even select a mill right now? I could select a mill, but I can't select a lathe. That's great. I mean, we're doing some stuff, I guess. I did see, did you guys, I don't know if you guys saw this. Hold on here. We're going to go ahead and swap things back out. I also lost my train of thought. Guys, remind me of what we were talking about there. I did see there was a bug with thread milling. They may have fixed it. Now let's go ahead and see. We need, it's going to be milling, thread mill, and tool orientation. It was quite entertaining. So from what I was told, it would crash Fusion when trying to do thread milling. See, I don't have that bug there yet. Somebody out there told me that there was a bug with it, but again, not necessarily on my side. So if you guys are having those issues, let us know. Last question got auto-corrected. The old controller with inverse time. Jerky positioning moves. The only thing I could really tell you off the top of my head is I think your problem is necessarily the jerky moves are more from data starving your machine than anything. Now, I would say is when you are concerned with data starving, if you look at this lovely toolpath here, if I go ahead and turn on my points, every single one of these points is a change of direction in any one of the, technically I would say 6 axes, in this case 4, because you have X, Y, Z, and B here. But your end goal would be is more or less to reduce the number of points to get a much more less jerky situation if you're data starving. Now, data starving on older machines is common. You cannot process code fast enough. This is why you could go in and start to turn on things like smoothing. Again, creating a maximum point spacing, and hopefully reducing, as you guys will see here, as I'm going to go ahead and turn on smoothing on this part, is I've now actually made the file 1,000,000 times bigger. This is also a full 4-axis toolpath, so it's added additional points with a maximum spacing of that dimension. So again, the reason why you would want smoothing like this is because you want the surface and finish to improve. But if we go back again, I'm trying to think if I have a good part here for this. We might be able to pull it off with contour. Again, there's our 3D contour toolpath. Again, showing our points. If I wanted to reduce the points here, this is again, somewhere where something like adjusting your tolerance a little bit or turning on smoothing. As you guys can see, there's now an additional tolerance. It's not fit points. And just like that, we've dramatically reduced the number of black dots on my machine. Now, this is valuable and it does help a ton, but I would say without knowing your machine, odds are you do have the ability to up the baud rate as well as change to high-speed machining options. Any other questions outside of that, guys? Opening it up to you guys. Chris, if you're still out there, I would be curious to know a little bit more about your machine specs, especially at 64 gigs of RAM, and what problems you're encountering. Again, to anybody and everybody, anybody here, if you guys have any questions at any time, have anything that you would like to see in particular, feel free to go ahead and leave a comment. If you're watching this at a later date, feel free to send us an email using the email link down below. Now, did you guys know this? We updated our website. You'll have to let me know if you guys like this. I'm going to pull up my website here on live. Go ahead and slide this guy over. Is now when you go to our Get Support section, you not only have the ability to email us a support question, you could also sign up for our support portal, which has a lot of our content listed there, track any of the tickets you may be submitting to us, but you could also fill out our fancy dancy support form now and go ahead and submit that to us, and that will auto-generate a ticket as well for you guys. So let me go ahead and check. I think we're down to the end of this. I don't see any other questions coming in. No reply from username. Anybody else out there? I mean, the screen resolution tip was good with George. That's a really good one. Another one, a couple of other ones here for performance issues. We did a video on this, but you could actually change your graphics preset as well. This makes a big difference from quality. As you can see, the quality now, I have reflective surfaces on my part, or switching out to performance only. Again, now my part looks much more jagged. Might be a little hard for you guys to see. Anti-aliasing is off. And in my case, I went ahead and went with custom, which gives me the best of all worlds. Well, well, well. Is that it? Are we done? Going once, going twice? All right. It's not what you guys know. It's who you know. You all know yours truly over here, Fusion Phil, and nonetheless, Evil Bill. And maybe next time you'll meet Will next week. Who knows? But with that being said, Emil, thank you very much. If you guys have any questions, again, feel free to reach out to us. We're here to help you guys in any way we can. And we look forward that, I mean, I got a lot of trees I got to cut down this weekend with the chainsaw. So I'm going to have a great time. And as all of you should, I hope you all also have a great time this weekend. Get rested up for Monday. I don't know. Should we do a video on Monday? Let us know. If you're watching this and you've made it this far, let us know if we should have a video on Monday. Go ahead and tell us in the comments section. But with that, I'm out. I'm going to go answer a couple of support tickets, and then I'm going to run a chainsaw. See you guys.